So I was going to talk a little bit about the Roboto project, but first I want to cover some of the basics and then talk a little bit about Android, just for the folks who aren't used to it, because I'm going to be using some of the terms and it won't make any sense if I don't. Just to tell you up front, there is a wiki page on our GitHub that has all of the code and has all of the points that are in the demo tonight. So just go to GitHub Roboto and you'll find it. So there's actually 3 ways to do Ruby on Android. The first one is through RoMobile. They have a Roads project, which is basically a cross-platform project. You can develop using Ruby and then deploy to different platforms. And like most of the cross-platform programs, they're using HTML for their UI. And so that's one of the projects. The other one's the scripting language for Android. That was a Google Labs project that uses many different scripting languages. It communicates to the main process and gives them a special API. So it's got a common API for the different scripting languages. We're actually in charge of the JRuby interpreter for that, and it probably needs a little bit of a refresh. But the main thing is that it's not the full Android. It doesn't give you full access to the UI and all the objects. It just gives you their own API and then communicates between the 2 processes. And I know that they're probably working on developing that, although I don't know how the loss of Google Labs affects that project. And then the last one's Roboto. The Roboto project was JRuby, just converted right over to Dalvik, and then creating whatever we needed to create to make the 2 interface. So our goal on the project was to make JRuby a first-class language, so that if you could develop it in Java, you could develop it in Android. So Android, Linux kernel, which isn't that important, but the Dalvik VM is. The Dalvik VM has a different bytecode. It's just set up differently. So Java code is compiled and then it's converted to fit the Dalvik format. And so that's a little different. When it comes to the actual applications, there's a couple things you need to know. The main thing is there's an activity. An activity is pretty much a screen's worth of information. It's the visual component. The service, which is more the background component. And there's other things like a broadcast receiver and content providers, but the main 2 ones are really the activity and the service, and just think of it as the visual and the background. The intent is the thing that you say, I want to do something. And it's a little bit of an abstraction layer to say, instead of, you can say, I want to launch this activity, but then the system is responsible for coming back with that activity for you. You don't just say new, for example. The other thing is you can say, I want to do something. I want to view something on the browser, and you don't necessarily care if it's the native browser or if the user's picked a different browser. You're just using whatever the user has chosen as their browser, their camera, their whatever. Okay? And then the last thing is the manifest. The Android manifest is the application sort of specification that tells the operating system, here's what I can do, the activities that I respond to, the services, the permissions that I need. So that's a static piece of information that goes with the application and allows the launcher and other applications to know what it can do. The challenge is when it comes to bringing JRuby over into Android is there are limitations on mobile hardware. JRuby wasn't specifically designed to operate in a low memory environment, a slow processor environment. Clearly the mobile hardware is getting better, but people are trying to push the Android operating system into many different devices. There's watches coming out with it running in it. So clearly there's going to be lower end devices and higher end devices. The Dalvik VM differences are fairly significant. And there's some limitations specifically on the amount of stack space that they're going to give you that we can very easily bump into as we're developing. The main thing is because there's a difference between the Dalvik bytecode and the JRuby, or in the normal JVM bytecode, you can't just use the just-in-time compiler in JRuby or generate classes and things like that on the fly that you can in the normal JVM, because the bytecode it's generating isn't compatible with the Dalvik VM. Okay, so until we figure out a way to either generate Dalvik bytecode or convert the JVM bytecode on the phone, you just can't take advantage of that. So that means we we have to figure out how do we transfer control when Android wants to do something, like you click a button and you want to say, I want my Ruby process, my Ruby script to get access to that. So that was one of the challenges that we were addressing. JRuby also has a lot of components to it that we're just not using. So those components make the application larger, and they really have no value to the person you're delivering them to. And then the Android resource framework, and by that I mean in Android you generate a resource to specify your visual components, to localize it between different languages, to different screen sizes, and all of that is taken care of at compile time. You can still do that, and I'll show you a little bit of that, but you can do it, but you have to recompile your application, so you lose a lot of the dynamics of a dynamic language. Okay? So really when it comes to Roboto, there's two components to it, two main components. First one we came out with was the IRB, which is just an opportunity to interact a little bit with Ruby as it's on the device, to put some scripts on there, and to run those scripts. And then the second piece that actually Daniel worked on last year as a Summer of Code project was to start to make something that we could generate a package, take that script, package it up, and actually ship it on the market. Okay? And so that's come a long way. But those are the two main components. They share a lot of pieces under it. They share JRuby, that's the most common piece of it. They share some scripts that run on the phone side that manage the interface between the Java and the Ruby side. And then they share these generated objects on the Java side that are knowledgeable enough to pass control over to the Ruby side at the right time. Okay? So what I'm going to do in the demonstration is start in IRB and show you a little bit about it so we can interact with it a little bit more. And then in the second part of it, we'll move into taking some of the stuff we've done, compile it into an application, and if the forces are with us, we'll just stuff it out onto the Android market. And anybody who wants to can download it. Okay, so first thing I'm going to do is run Roboto IRB. It was already running, so sorry I didn't kill it. And so basically, just a simple little environment that we can interact with. And then get values back. Over here is the scripts. You can edit the scripts, but I have to say, editing scripts on a tablet is better than editing scripts on a phone, but it's not that much better. The keyboards just don't get it for you. They just don't provide you quick enough access to some of the things you need. You can do it, but I wouldn't write your program on here. First thing I want to do is I actually want to run I want to run a new demo. This version of Roboto IRB was shipped last night, the motivation of having a demo today. So it gets everything up there. So what I did is I just ran, and I'm going to show you the code in a minute, a WebBrick server on the device so that I can get access to it over here. Okay, so all I did was pull up this eval, and I can actually just go ahead and evaluate things on the device, but I'm sending it over to the WebBrick server. And then I can look at the same files that are on the WebBrick server or on the device, and I can run those. So the first thing I want to do is I actually want to mount the demo, so I have another little bit of code, and then that's now available to me. Okay. So basically, here's the code that we're running. Not that we want to go through it, but if anybody's ever used WebBrick, you give it a little bit of code, you say you want to mount this procedure on a particular thing. So I'm mounting something on the root, and I'm mounting something on scripts, and then I'm giving the capability to say I want to run that script, and it just sends it back over, and it loads that script in and runs it. The only things here that are actually Android components are I'm importing some stuff that I'm going to use I'm going to use to send this notification down here. So I send a notification to say, here's the port that I'm registered on. And then at the very end, of, sorry, I ran the at the very end of my WebRick server, I'm launching this in another thread, and I'm starting a service around it so that it's running in the background, so that if this thing shuts down, it won't stop on me. What I want to do, though, is I want to go into the demos, and I wanted to show you a little bit of these demos. Okay, so first thing is just to say, when you're talking about an intent, so the first thing you need to do is you need to fire off intents, and a lot of intents you can fire off to get other applications to do your work for us. So in this particular case, I'm basically saying I want to do an action image capture, and when I evaluate that code, it runs the camera on me, allows me to take a picture, and then can return control. And I'm not going to do it right now, but you can get that picture, get access to that picture. So if you have an application that you want to take a picture on, you don't have to write a camera application. You just tell the camera application, take me a picture, and let it do that work for you. So the same way we do that, we can launch a browser. Great, because this is a brand new computer. We can launch a browser, or we can map a location. Okay. It's actually, when it tries to figure out where it is, going to try to go to Engine Yard, but I'm not going to wait for it. Okay. So that's just firing off an intent. It's not that interesting. Ultimately, what we want to do, though, is we want to come up with our own activity. So now we're actually getting into Roboto doing this. So normal JRuby, you get to import your objects. The require Roboto activity just says I want the activity components of Roboto. And normally in Java, what you would do is you just say start activity. Here you say start Roboto activity. This is the sort of the next component of it. The onCreate is part of the life cycle of that activity. When I fire up my activity, I don't actually say new activity and have the object right in front of me. I say I want this activity, and I have to wait till it comes back. So what Roboto does is it just takes that block that you called, waits for the object to come back and say, okay, I'm back and I'm here, and then it evaluates that block on the new activity. So now that new activity has an onCreate, which is just one of its callbacks. So during the creation process, it says onCreate, onStart, onResume, and I'm saying I want to do something when this activity comes back and creates itself. And the only thing I want to do is I want to throw up a text view and put some code in it. And so when I evaluate that, it throws up a text view. It says Domo Arigato. That's because that's what, when Charlie did his first blog post about Roboto, he said Domo Arigato, Mr. Roboto. So, and then I touched it, so I get a click event, which is interpreted right here in a procedure, and it just says change the text. Okay? So all I'm using there is the activity framework. Slightly more complex is the second one, which says it's not really that fun to write that code where I take a view and I have to continually call back into it. So part of the widget framework for Roboto is to take a whole bunch of pieces of information and pass them into that new text view that I want to create. So in this particular case, on my onCreate, I'm doing something a little bit more complex. I'm creating a bunch of different visual objects, and I want to just lay them out on the screen. I want to have them flow correctly on the screen, and then I want to create a bunch of those text views. So when I evaluate that, it comes back up with the 4 of them evenly spaced, and then again interprets the click events. Okay? It's not that complex. It's just showing you that the widget process is trying to streamline it a little bit for you. Okay? So you call the layout, you stick a layout inside it. I created a separate method call because I'm going to create the same text view over and over again. So I just do that in a single place. And that text view is the most complex. I have to tell it how to lay out. I have to tell it what size the text is. I have to change the text back and forth. And so I'm doing that all here in the on-click listener. And it's really the magic of JRuby that is taking that procedure and just turning it into an interface. Okay? So here's a slightly more complex one. In this particular case, the thing that we have to do here differently is JRuby can handle an interface that has a single method on it. But as soon as you have an interface that has 3 or 4 methods on it, you can't just handle that with a procedure. So this is what one of the things we had to do with the Rubato project was we had to, in every case where we wanted to use an Android object that we wanted to pass control back into JRuby, we needed to subclass it, and then we needed to allow the Ruby side to register a particular procedure that it wanted to run when a particular thing happened. So in this case, it's actually gone off the screen there a little bit, so let me. In this case, it's importing a surface view for the camera. It's an object that's going to display the camera information for us, and it has a couple of different callbacks. And one of those callbacks is right here, on surface view created, on surface view destroyed, and those are going to set up the camera activities for us, but they're going to pass control back to us. So when the activity is created, it does an onCreate block, so it can set up its interface, and its interface, it sets up that surface view. It sets up this click listener. What do I want to do when the person touches this surface? And configures it a little bit. And then down here, as soon as the surface is created, it calls in and it opens up the camera. It gets control of the camera. So if I again evaluate that code, okay, it brings up my camera again. It's not showing that, is it? Okay, well then you're going to have to look at it this way. And it allows me to touch the screen. It takes the picture, stuffs it back into the system. But now that's something I've controlled. So it doesn't have all the extra controls around the camera like auto-focusing and things like that. But if you wanted to build your own camera application, you could do it. Another one of those that needs some additional work to it is the surface view for the OpenGL process. So again, we tell the application, I need you to create a surface view for me. It subclasses it or creates an instance or a class that implements that interface, and now we can interact with it. So Rubato does all that for you. What we had to do, though, to do this is we had to look at the entire Android API and map it. So it's basically, through Rubato, it's stuffed into an XML file. And when you say, I want to create a subclass of this particular object or an instance of this particular object, it has to go out there and figure out what are all the possible methods that you might want to subclass and be able to call on. And then you can control which ones you actually implement. This is a little bit more complex, but to do this, all I did was went to the standard Android demos and said, I want to see something spinning around on the screen. I found one of their demos that did this, and I just converted it over to fit in our format. But it's pretty much their code. And so when you evaluate, I'm hoping this will show on the screen. Yeah. Okay. So that's calling back over. I haven't done any timing on it, but it's calling back over into the JRuby process, into the script every time, and the JRuby script is updating it. So it's still pretty pretty snappy. It's getting a decent, frame rate response here, and just spinning those around. So clearly you can do a decent amount. The biggest limitation is really more on startup and not necessarily on the ongoing spinning. I'm not saying you want to write a third-person shooter in Ruby, but you can do a significant amount of graphics in it. Okay. And then switching off of that for a minute, a couple of things that you get on a mobile device, right? You get the hyperconnectivity of having broadband, Wi-Fi, NFC, Bluetooth, all kinds of different ways that you can communicate around you into the outside world. And then you get a whole array of sensors. You get your GPSs, you get your accelerometers. There's a reason that they're taking these devices and strapping them to rockets and sending them up into space, because normally you'd have to spend millions of dollars designing the equipment that is now in your phone, and you just tap all those sensors. So in this particular case, all I was going to do was evaluate the last known location. And I don't know, because this tablet's brand new, whether it actually has a last known location. But I think it just took us to 3rd Street, hopefully. Took us to Engine Yard headquarters. So I took the location that I could get from the sensors and passed those, sent the same tag that I sent before, but said, bring me to this longitude and latitude. Okay? And then finally do a little voice recognition. This again fires up an intent. The intent sets up the speech recognition, says what it wants to do, and then fires off that speech recognition intent, and then gets the callback. So when the person's done speaking and the processing is done on that language, it sends it back in on activity result callback. Engine Yard, San Francisco. Okay, so it again tells me it's searching for Engine Yard in San Francisco, displays that information, and you can actually see, it's a little bit small on the screen here, but it comes back with actually an array of options for you. The first one, I just take the first one, so it comes back and says Engine Yard, San Francisco. It also says and Union, San Francisco, Engineer, San Francisco, Engine Yard, San Francisco, and you, New York, San Francisco. So these are the different possibilities. But the first possibility is the strongest possibility. So I just took that and punched it in and said to the mapping program, take me there, whatever it got. Okay? So that's just showing you that you can access all of these things. All right? So I was just trying to run through a little bit of the demo to show how a little bit of script can access the different components of Android, and then what happens. So a little bit more complex activity is this JRuby Meetup demo activity. What this is going to do for me is it's actually going to load up a list, display a list of options, in this case, list of possible demos. When I click on it, it's then going to pull up that demo. When I evaluate it, it's going to run that demo. So this is an application that's pretty much got sort of those 3 layers. So when I run this activity, okay, it comes up with my list. This is just the same list of demos that I was running before, but it went out, found them in the file system, and built a list and stuffed it in there. And so now, if I click on any one of these, just because I like seeing cubes spinning, I can click on that. It pulls up a text view or an edit text view with that information in it. You could make a change to it, and then you hit evaluate, and it runs it. So it's running it inside of the context of the application that I just put up there. Okay? So before, from here, I was just saying there's a script out there, run it. In this case, I'm running a script that's loading a list of scripts, that's showing you that script, and then evaluating that. It's checking to see if you changed anything and just going ahead and evaluating it. It's doing that all inside of JRuby. Okay? So that's interesting. You can run these little scripts, but ultimately IRB is going to be limiting to you. If you want to ship an application out to the market, you need something more. So let me show you how you do that. So we're going to close out of the IRB server, and I'm going to switch over to this computer for a minute. So the first thing you need is you need to set up your environment. And let me just show you what that entails. So if you want to run now we're getting into Roboto Core, you need a couple of things in your environment. You need Java, you need the JDK, you need Ant, you need Ruby of some kind. At this point, it doesn't care if it's JRuby because it's going to get its JRuby from somewhere else. You need Ruby Gems and Rake. Then you need to load down the Android SDK and all the different platforms. So through the Android SDK, it gives you some development tools, but then it also allows you to pick all of the different platform levels from, well, they probably don't have them all out there anymore, but down from 1.5 up to 3.2. And so you load those down, and then ultimately what you're going to be telling Roboto is, what platforms do I want to deploy on? You never deploy on a single platform. You want to deploy across platforms. So you have to tell Roboto, I want to deploy from Android level 7 up to Android level 12, and Roboto has to figure out what's available to you. And if there's a conflict, you have to tell it then, do I want to include this particular callback or not? On our website, you can get the full walkthrough of how you do the installation, but that's pretty much a script right there that would take you from a fresh Ubuntu install to being able to compile your Roboto code. So it's just downloading all those different components. Okay? So that's pretty much what I've got here. I've got a virtual machine here running with Ubuntu in the background here. So I've got 4 gigs dedicated to that. And the first thing to do is switch back over to the demo wiki, because that's got all the code that you would need to run. So it's got the setup information there. But this code right here is the code that you would run. Let me zoom in on that bit. Is the code that you would run to generate the Roboto app. So at the command line, you say Roboto app generate. You give a package name. It can assume the name of your application from the package name. You tell it the target API levels, or it'll just assume them. And you tell it the target one, and you tell it the minimum one. And so it can look at that whole range. So I'm just going to run that. Okay, so it's generated your application now. All right, it loaded everything it needed in there, including the Roboto RB scripts. It generated on-click listeners. It generated your Roboto activity, which is a subclass of activity, a subclass of service, a subclass of broadcast receiver, a subclass of view. These are all things that are now available to you if you want to use them in your application. Okay, so I can switch into this new application and Rake debug it. Now something actually brand new just within the last couple of weeks. Before, what it did when we did that build is it actually took JRuby from the JRuby jars gem and put a version of JRuby in your path here. And then it had to compile that in, and it ended up generating about a 10 megabyte application. Even if it was a small script, it was a 10 megabyte application. And that was pretty much JRuby and the standard lib. So now what we've done in the last couple of weeks is we've been able to separate that out. So now the application that's generated is just your stuff. And then it can pull from the market the core which has JRuby in it and has the standard library in it. So that's the bulk of the package, but it can then be reused by different applications. So if I copy this newly generated app and I just put it over in my Dropbox. Okay, then I can come over to Dropbox over here. The reason I'm not hooked up to this is so I can hook the tablet up to the screen there. I can't also hook into it. But normally you could just transfer it over directly. So here's the JRuby Meetup demo debug. And it was generated 10 seconds ago. I can install that. And in and of itself, it's so it installs it. It asks me to go to the market and install the core piece. It finds it. Oh, come on. Okay. Takes a second. Okay, so it's detected it, and the application that I put on there, which is just the default application that we generate, just comes up with a button, allows you to click on that button. So that's just the default application, doesn't really give us anything, but it just shows that it's working. So the next thing we need to do is, if I go back to the wiki and look at what's there, it says I need to copy my demo scripts over. So what I'm going to do is I'm going to take that last application I showed you that took the list of demos and ran them, and I'm going to compile that into our application. So I need all those demo scripts into my application. So if I sorry, not a typist. Oops. It's not going to do this for me. I need to make so I make an assets directory, which is where it's going to hold things, and I copy the demos in there. The next thing I need to do, since it generated a base activity that I can show you here, if I open the source directory, it generated a JRuby Meetup demo activity, and that's just the default activity. That's, of course, not what I really want. So I'm going to just copy the script. It's going to be the same script that we ran on the device. JRuby Meetup demo, and I'm going to stick that into source. Okay, so that's getting my scripts in line. The next thing I need to do, well, I've already got this in there. I had one other script which is just going to say what this application is, because otherwise it wouldn't really speak for itself. And then two of those demos that we ran actually needed additional objects generated. IRB had those objects already generated inside them. But here's those two activities. So I need that surface holder, Android View surface holder, and I'm going to make a new Roboto object called Roboto surface holder, and I've got the same thing for the GL surface view. So if I take those and generate them, it loads up the Android API. It figures out what methods it needs to implement. Since they're interfaces, there's not a lot to decide. It has to implement all the methods in those interfaces. There's no differences. If there were problems, like in a particular version there was a new method added, it would probably have to flag that and say, do you want to, well, with an interface it doesn't have a choice, but if it was a class, so for example, when we're generating the subclasses of activity, it needs to decide, do I add all the new stuff that was added in the last version, because that's going to crash it on earlier versions. So it makes some assumptions on those, but it gives you that flexibility. Sorry, to do that for both objects. And while it's doing that, the other thing that I need to open up is my manifest. So it generates the default manifest for me. Okay, but I need some permissions, right? The basic application in Android doesn't give you any permissions. I need permission to get to the camera. I need permission to get to the file system. I need permission to get to the network and the Wi-Fi state. So I'm again gonna just copy a new version of that. And I'm just going to copy it right here. Oops. Okay. So if I open that again, what it's done is it's added the permission to the internet, the location, the network, the camera. And I've done one other thing there, which is I've told it to allow the application to handle the orientation change. Because the way that Android was set up initially, to me, was kind of stupid. If you reoriented the device, it reloaded the activity. And so that can cause us some problems. But nowadays, they allow you to say, hey, I don't want that particular behavior. Okay? So we've got our permissions. We've changed the orientation. The next thing I need to do, if I'm actually going to put this thing on the market, is I need to generate a key. So I need to sign the application. Okay, so it generated the key for me. So now it's given me what I need to put it into the market. I'm going to copy one more thing, which is a set of build properties, which it allows it to sign the application in the build process. And now I'm going to say, oops, it's not going to do that, is it? Okay. Okay, so it's built the application. I can copy it again. Okay, so 7 seconds ago. See if it allows me to install it. Because the previous one was a debug build. Application is not installed. Okay. Sorry. All my son's games loaded on here automatically, so that's. Okay. Oops. All right. Okay, so it doesn't have to reload Roboto Core because it finds it. This is the startup slowness, but now that's our application that we just generated. It has the list, it's pulling it out of the assets, and again, we can make cubes spin. But this is now a fully packaged APK that can be put out on the market. I don't want to take your time necessarily doing that right at the moment, but I can put it up on the market this evening, and it can be available for download from anyone. All you have to do to put something up on the market is take that APK. You have to have a market account. It costs $25. You upload the APK. You give it a couple of pictures, a couple of screenshots, and then maybe it might take an hour or two to clear through the market before people will start seeing it on their devices. This would be available on devices from 7, which is 2. I think that's 2.0 or 2.1. And up. Okay. So where are we in this whole project? There are some sort of things we haven't tackled yet. You saw the startup speed there. It took a little while for it to go. Not huge, but 5-10 seconds. And if you're loading up a lot of objects, it's going to take even longer. That's something Charlie's looked into, hasn't had a chance to tackle, although he tweeted something about it the other day that he's working on. This is the same sort of JRuby startup speed, but when you put it on slower hardware. We got some stack limitations. That's because Android limits the amount of stack space that you have. And in most cases, that's not a problem. But JRuby is a little bit more of a stack hog, as it's never had to worry about it before. So calling from one block into another block or embedding blocks there, you could lose 20 frames in your stack. And so sooner or later, you run out of stack space. The main place that you're going to hit this is either in parsing your Ruby code or in embedding widgets if you're building a UI. The one when you're loading code is really easy to solve because you can wrap it in a thread and just load it in the background, and you can specify how much stack space you want. The only thread that you don't have control over the stack space is the UI thread, and so that's really where the problem comes in. App size is still pretty big if you want to put it out there yourself. If you want to share the core with other applications, then the application is really tiny. You have to, ultimately we'd like to be able to compile Ruby so that any of the speed issues would go away. We can compile it, but right now it's just a little bit too big. And we'd love to be able to generate bytecode so that you didn't have to do this whole negotiation problem with, where you could just generate a subclass of a Java and build it on the fly and build it in your script, but we can't do that yet. And then also, we had to build an XML specification for the whole Android API so that we could figure out what those callbacks were so that we could generate subclasses of them. There are other libraries that somebody might want to use, other libraries they might want to bring in, other libraries like the Google Maps library, which is a separate library, or even the new compatibility library. They're just other libraries that might also have callbacks that we want to control. So that's sort of where we are, and those are the things that we're still tackling. So if you're interested in getting involved or using the project, Roboto.org points to everything else. The Google group is pretty much where we talk about issues or where we're going, what's coming up. And then GitHub has both the IRB and core so that you can download those, play around with them, build them yourself, tweak them, add things to them. It's also where the issues are and the wikis are. The one other demo that I kind of wanted to do for you, but I just didn't get it under control for today, was there's a good demo up there for if you want to use Bundler to take some Ruby gems with you into your application. I was going to do it by taking JSON and the meetup gem, bringing them in, and then I could hit the meetup API and pull in the information, for example, about the people that said they were going to be here this evening. So you can do that. You can bundle gems. They've got a demonstration up there about how to make Active Record run on there. I don't necessarily suggest you do that because Active Record is a little bit of a memory hog, and on a device this size, it probably doesn't make sense. So if people wanted to get involved, obviously just picking it up and using it in any way, shape, or form, pressing on different areas of the APK, tackling different features, bringing in different gems, and seeing what works. Obviously, the Android API is a huge API, and there's a lot that I haven't even gone in and explored. In most cases, when I go in to explore things, I can figure out a way to make it work, not necessarily the way you would do it in Java. Ultimately, if there are things that you can't do in Ruby, like you can't build the XML and then compile it in, you can still do those things over in Java. You can put an XML file to specify your UI and then compile it. You can do half of your application in Java and the other half in Ruby. However you want to do it. My goal has always been, I'd rather never have to, after I compile the application the first time, I'd like to do everything else with just updating scripts. Every once in a while you need to compile images or other things in there, other libraries. Okay.